1, 2, 3. That's better. So welcome back, everyone. Hope you had a great lunch. I thought it was absolutely fantastic. So the next thing we're going to do is a panel on the future of SDN, and I'm going to introduce the moderator. So I'd like to welcome the panel moderator, Farouk Nair. Farouk Nair is the Chief Information Security Officer at ORION, which is a position shared by 8 post-secondary institutions in Ontario. Previously, he was part of the cybersecurity and privacy team at PricewaterhouseCoopers in Canada, where he led several cybersecurity engagements. So welcome, Farouk.
Thank you, Brad.
You're missing somebody.
Hattie. Yeah.
Okay. So I'm assuming everybody can hear me, right?
I'll go get Hattie.
Okay, so we're just missing one panelist, but thanks a lot, Brad, for the introduction. We are just waiting for another panel member to join in. So in the meantime, can I request all the panel members to just introduce themselves? Rich, we can start with you.
Yeah, hi. My name is Rich Tazone, and I'm the CEO of an organization called Center of Excellence for Next Generation Network, CENGEN, and I'm based in Ottawa.
Thanks, Rich. Yep.
I'm Yatish Kumar. I'm the CTO of Corsa Technology. We're an Ottawa-based company, and we build programmable hardware. So 10 gig, 100 gig hardware that's fully programmable.
My name is Mark Cadet. I work for the Canadian Internet Registration Authority. We run .ca, and I'm a product manager there for DNS security products, Anycast DNS products, and I'm based in Ottawa as well.
My name is Hadi Banazadeh. I'm Savvy Testbed Chief Architect, part of the Savvy project and project headquartered at the University of Toronto.
Thanks everybody for the introductions. So I'll start off with the session now. I think the first thing which I wanted to talk about on the open platform is that what are some of the upcoming projects on this platform and how will they impact our community. So probably Rich, we can start off with you.
Yeah, sure. So if you were at my earlier session, I talked about participating in the OPNFV, the Open Platform for Network Function Virtualization. The reason why we're involved is because it's based on the view of a user. So how would a user, a service provider, a large enterprise customer, an academic institution, how would they actually use the technology? And because that's what I'm interested in. I want to use stuff. I'm interested in giving back to the Linux Foundation, the Linux community, but I view ourselves as a user, and I want to do stuff with the infrastructure, but I also want to do things over the top of the infrastructure, so use it. So there's a lot of projects, as was mentioned, from the Linux Foundation, from many others, and quite frankly, it's hard to keep track. Like we live and breathe this every day, and there is so much going on. You gotta basically survey the landscape, figure out what's important to you and your organization, and basically, double down in those areas. And I think more importantly, you actually have to live it, right? So live it, breathe it, try it out. And I like the model of the fail fast. So if you've got some software, some cloud infrastructure capability, containers, whatever's important to you, try it out, find out if it's a fit. If it's not, drop it and move on.
Oh, thanks. Yeah. If you can.
So could you repeat the question?
Yeah, so I was actually talking about some of the upcoming projects and how will they impact the community.
Right.
So
we've been working for the last 3 years with the R&E community, and we have OpenFlow switches installed in test beds in Europe in the GEANT network. They're installed in the US under the Genie program. And they're also deployed in the Energy and Sciences Network as yet another sort of large topology. And through those networks, we then work with the people that attach to those networks in order to do interesting things to them. So, for example, we try and collaborate with the LHC project because they are one of the largest users of networking capacity to talk about what they want to see happen in the next few years in terms of the way they load the network. We're involved in things like a new telescope that's being put up in Chile, and they have some very unique needs about how their traffic should be handled as they run their traffic into computers in Chicago without storing intermediate sort of data files. And so we don't have such a thing in Canada where we have test beds that are available for people to work with. We would be very happy to work with the community to set something up in Canada and then federate it with all of those other test beds. So you don't have to feel like you need to build a very large system that's exclusive to Canada. All of these sort of multinational test beds are very easy to federate, and you can build very interesting things on top of them. And so my offer to anybody that's interested is come talk to me. I can tell you what's going on outside of Canada, and I can tell you how you could possibly collaborate with these people and sort of do more global collaborations on future networking research.
Good. I think that's a really good suggestion, and I think all the attendees should leverage this opportunity to work collaboratively in Canada on this. I think just before the panel discussion started, you mentioned that you did something around security, also developing an appliance or working on that. Can you talk about that briefly?
Yeah. So security is separable from programmable networking, of course. When we go around, it sort of stands out as a very important theme. And I was noticing even today in the first panel session in the main ballroom, we quickly moved from innovation to talking about security most of the time. And I've spent 3 years, interacting with thousands of people in R&E, saying, well, what's the use case? Why do you want to make a programmable network? What's different? What are you complaining about in the first place that's not working for you? And often the things are multi-domain connectivity, being able to seamlessly connect across multiple R&E domains. And the other is QoS, and then the third is security. And security generally lands more on the campus end of things because that's kind of where the problems are, and people running core networks are not as concerned about security. And so we basically have taken the SDN approach to solving or providing a solution for security, which is there are thousands of different exploits and attacks and things that happen, and everybody has a different methodology for how they cope with, how they deploy their sensors, what are they sensing, what data are they gathering, what attacks do they feel they want to mitigate as an IDS and IPS, what is it that you're building? And everyone's a snowflake. Everybody's a little bit different. And so what we've done is we've built hardware that separates the mitigation, the act of mitigation. So at 100 gigs, when packets are coming through, you're going to either block them, deny them, allow them, rate limit them, redirect them, copy them. Those are sort of primitive functions you want to do. But we offer that to you in a raw format. You can now use a Python script, or you can use REST APIs or BGP flow spec or whatever is interesting to you in order to activate those actions on the packets as they move through the data plane. And that allows you to then go through your own security methodology and say, okay, well, this is the collection of intelligence I have. Now when I want to act on it, I can relatively simply script the actions that I want so that I can implement the mitigation. And so we build programmable open mitigators that run at full line rate at 100 gig, 150 million packets per second kind of thing.
Okay, thanks. Mark, from your perspective?
Sure. From my perspective, I'm interested in the security aspect of open networks. We're not actually involved in developing SDN or rolling that out. What we are experts in is DNS, and we're rolling out a DNS firewall service. So this is a service that looks at every DNS query coming out of a network and compares it against known malicious domains, malware, ransomware, as well as content filtering. And I could see areas where this could be integrated into an open network where you could redirect all DNS traffic to a security appliance, apply policy to it, whether to allow it or block it, and then actually do feedback information from the information associated with the domains that are being looked up and apply policy at the edge, whether you redirect that traffic to a proxy server or block it or give it a higher level of service or redirect it to be inspected further.
Right. So just to build on that idea, the notion of federating your intelligence is a good idea. And so again, as a community of researchers and R&E people, if you have sensors and you detect threats and you can find a bad actor on the internet because they attacked you, if there's a way for you to share that information and then have it trickle back downstream, then the entire community gets stronger as a result of it. And then you can go and take that and you can either, because it's a DNS type attack or it's a port scan from some strange country or whatever it is, building up a database of known things that you have experienced and then automatically sharing it with others allows sort of a much stronger security solution. So those, I think, are the types of ideas that are worth exploring and doing something about in the R&E space, either within Orion for Ontario or across Canada or whatever.
Yeah, that's a good idea, and there's some work being done in that space right now. So Canary, which manages all the RANs across Canada, is currently working on a joint security project, and they're coming up with an approach towards detecting any kind of malware or attacks or active or passive scanning and sharing the intelligence with the other stakeholders.
Yeah, I think that's a great idea.
Yeah. So Hadin, up to you. I know I attended your session about Savvy this morning, so if you can tell us about, is Savvy going to be evolving in the future? Are you working on any related upcoming projects?
Yeah, as I mentioned, our goal is to put together the infrastructures that we have and the application framework, open application framework that we have, and move it toward smart cities and Internet of Things. So how to create smart city clusters. You have a very kind of similar challenges and at the same time sometimes different. You'll be able to create infrastructure that and a set of open applications with open APIs to be able to share data, share resources, share applications, and sometimes quick application lifecycle deployments in terms of being able to bring in DevOps principles to this environment. So that's the directions that we're trying to move toward. Basically, from the macro, from the VMs, from the hypervisors, VMs, networking, SDN, all these features and virtualization that we have on top of it to bring the microservices and the open application platforms that is on top of it, and to provide services to cities to improve quality of life. Let's say you've seen an applications that we had is about doing analytics on these data that's collected, like what would be the border crossing time tomorrow at 10 a.m. given the history of the delays, or what would be the traffic time tomorrow at this time, or so somehow finding doing better decision making using the open data streams that is available. So it's to central to it, I think, is the being openness in terms of the data streams, infrastructure that is software defined and it's allowed to manage it and configure it in a very flexible manner, and platforms that is open, that is allows these information sharing between devices. That's the directions that we're going into Savvy project, and how to make our infrastructure geared toward that type of environment. That's what we're looking at.
Okay, really good thoughts, especially on the side of IoT and big data. I think that's the way to go forward, and then I think there are security risks attached to that. So I'll be talking about that in a while. But I think since we touched upon SDN also, and we spoke about using some kind of web application firewalls or some kind of security controls around the open architecture which Mark spoke about. So I think that is also critical. So I'll just change gears now, and I'll move the focus of the discussion towards the SDN infrastructure now. So since you're sitting right next to me, I can just start talking about that. So can you just talk a bit about the SDN infrastructure? I mean, what kind of investment is required for the SDN infrastructure? What kind of resources are required? And how will that evolve? So just briefly about that.
Yeah, one of the main challenges of the SDN so far has been how to basically be able to roll out into legacy networks, the current networks that we have, how you would like to apply the SDN. Obviously, SDN has a lot of potentials, security being one aspect of it, dynamic security management, NFVs and stuff like that. But it's been very slow to be deployed in legacy networks, and people have. I think one of the reasons is that people have thoughts about how much change you need to put in network. You need to change everything in the network, or what are the? We believe it should be baby steps. So it should be a step-by-step introduction of SDN. Maybe the best place to start is the SDN at the edge, maybe at the access, smaller areas, and going from there, building up all the way, or some isolated environments that you would bring in, because it's not only about the features and the technologies, it's about how to change a little bit the way people look at the network, work with the network, the people that operate the network. So it should be a gradual change to be able to bring about those changes. I think if that, until we don't have that migration strategy, it would be very difficult to see any change toward a better networking in future.
Okay. Rich, your perspective on it?
So we've had our cloud in production for 2 years. So it took about 6 months to kind of plan what exactly we wanted to do, right? So again, it's not about playing with technology. It's taking technology to solve a business problem, right? And the problem that we wanted to solve was we wanted to build one infrastructure, do it right, and use it many times, okay? And dynamically and virtually software program. So we have about, I'm going to say 10 full-time staff, kind of, you know, regarding the operation, the development of our Shenzhen cloud. And we have about 15 students as well every 4 months. So part of our mandate is basically to get students involved because, well, look at me, I'm no spring chicken. At some point, I got to hand over the reins to the young talent, and you know, we'd like to train them. So basically, there's 10 plus, you know, let's say at least another 10 students that we hope will really like this type of work, and you know, obviously we'll want to continue their career in that space, and you know, stay here in Canada instead of going down to the valley, right? So.
Okay. Mark, in fact, your perspective, Corsair's perspective on it.
Well, to answer the question, you have to consider a few different domains. What is the cost of starting up an SDN project on a campus versus what is the cost of doing that at Canary or at Orion? On campuses, I think the useful things I've seen with SDN are either reworking your layer 2 switching infrastructure, in which case you're talking about repurchasing some Dell or HP switches, if you like, with some limited amount of SDN capability, or finding a way to insert SDN into, say, the spine of your campus network and leave everything else alone. And why would you bother doing anything at all? Why do you want to reprogram your layer 2 or layer 3 in a campus? I think it's security is actually probably the most interesting use case. If you want to stop east-west propagation of viruses, for example, once they get past your firewall, what other controls do you have? Maybe you have endpoint security on laptops and things, but then you're fighting the virus on the same platform. So things like default deny policies, where departments can't actually talk to each other unless specific applications or protocols have been approved. That's a great kind of thing that you can start to introduce if you have SDN touching those packets somewhere along the way. I think the cost to do that is not terrible. There is some amount of effort and intellectual cost to doing it, but that's the interesting part of it. And with a few grad students or a couple of guys, you can make some progress. On a different scale, if you talk about, say, the Energy and Sciences Network or GEONT, they're talking about rethinking their entire core network. And so they spend millions of dollars right now on the technologies they have, MPLS and large core routers and so on. They are spending a few $1 million building up SDN testbeds in order to prove what they could do so that in 2019 they can save, say, 70% of their CapEx and a bunch of their OpEx. Different scale. And so it depends on who you are, but in most cases, it's not free. It's probably going to drag all of your spare money and capacity that you have in order to do it. If you're in campus mode, it'll take a lot of your time and money. If you're GEONT or ESNet, it also takes all of their sort of disposable cash and effort in order to actually make decent progress. So you got to pick your battle, and then once you picked it, it'll consume what you have.
Thanks. So shifting gears a bit now, I actually want to drive this discussion more towards security, so I think this is the best time to talk about that. So let's talk more about the security challenges and implications of SDN. What do you guys think are the key challenges, and how has the architecture evolved based on that, or has it evolved or not? So who wants to answer that first? Rich, you want to? Yeah.
We're using open source firewall in an NFV mode, so we're using pfSense, and I think it's appropriate, kind of just given the fact that we try and use open source tools and technologies wherever we can. That being said, security has many facets to it, right? So one of our members, Electronic Warfare, they actually designed our cloud from a security perspective in mind. And the reason why that was so important, twofold. Number one, when we became live, we were under attack immediately. So immediate. So obviously people are interested in what's going on. And the second piece is that we actually operate in a co-opetition. So basically every industry member of Sengen competes with someone else who's also a member of Sengen. So for example, Cisco competes with Juniper, who competes with Nokia. Bell competes with Rogers, who competes with TELUS. Right? And so when they have some intellectual property that they want to do a proof of concept, they may not want to share that. So that information needs to be kept within that container and project space. And so I guess from day one, actually even before day one, we had to make sure that security was kind of fundamental to the design.
Okay. Do you want to answer this question, Mark?
Well, I guess my perspective is more from providing a service on the SDN, but as soon as it's out there, it will be attacked, and there'll be exploits at every level, and integrating security services into the infrastructure and configuring them will be a key aspect.
Yeah. I would like to know Corsair's experience with that. I'm sure you guys have lots of experience in that space.
One of the things I was talking about in my talk is we're kind of stuck with all the protocols and vulnerabilities we have because the internet has grown organically since 1973 when people didn't even think about security. We can't change everything, but if you slice off parts of the overlay network, you can rethink a lot of stuff. And so the Quick protocol, for example, that I was talking about that Google implemented, has security inherently baked into the protocol. And so at least in that small domain where Chrome is talking back to Google, security is not an afterthought. And so it puts them in a much better position to not be sort of broken down every 2 minutes. And so I think with SDN, we have the great opportunity on overlay networks or edge attachment protocols to redesign everything from scratch if we want to. And just because 90% of the rest of the world can't use what you have, for your domain, it's still a very valuable thing to do. If it catches on, the 90% will convert. I think the other problem with security is side channel attacks. And those are like, I've sensed the power supply on your typewriter and I can figure out what you're typing. Or I can launch a VM that's coexistent with another VM on a server, and I can still figure out how to crack your VM. I think those problems will always be there, so we'll never ever be completely safe. But I think if we just focused on sort of in-band, non-side channel protocol design and implementation of security, we can get there. And some well thought out work on that, I think, is very much in line with SDN, either giving you access to the control plane, and so things like DNS peering policy, you can start to write software which makes your peering a lot more secure. You can implement RPKI, you can do BCP 38, right? And so SDN gives you the control plane. You can make the control plane more secure. It also gives you the data plane. You can also make the data plane more secure. You can build assurance into the protocols you're sending because you can add more data to a packet if you want to. I think those are the fruitful areas. And I think as if we chip away at it, then we will get out of the fact that we're always patching things. We have these vulnerabilities, and now we're trying to figure out a way to work around the fact that they're vulnerable and be more assertive and make things that are inherently safe. And I think that is the kind of thing to work on. It'll take many years, but that's kind of the way I would see security going in the future.
Okay, thanks. Your thoughts on it?
Yeah. So SDN, from one of the main benefits of moving toward SDN, I think it's security. It brings in a lot of capabilities that is not readily available in legacy networks. Like, for example, in our system, every flow in the network has to be authorized. So if there's no authorization at that level on every flow, it's not going to get through the network. So it's kind of fundamentally different from the ad hoc way of things that used to be when you look at the capabilities that you could do in SDN. So many things are authorized, established. Many things are proactively set up instead of being reactive set up. And that allows brings a lot of advantages in terms of who can scan what, spoofing, many of these things that you don't want certain traffic goes from one to the other. And that allows, especially behind firewalls inside the systems, because usually when someone passes through the firewalls, comes into the system, the hackers come into the system, usually they have the free access to everything kind of thing. So you go from one to the other, they jump from one node to the other. So SDN allows those, especially in contained environment. If you control it with SDN, it gives you a lot of control of what's going on. It has very a powerful monitoring capabilities, so you could see all the types of traffic going on. We have projects that would just monitor SDN traffic. And at the same time, because it's such a powerful thing, you have to make sure the SDN controller and the control logic is not get compromised too. So that's basically the downside of it. So it brings with a lot of capabilities in terms of being able to better handle security problems that many of you may have faced, but at the same time, you need to be very careful about the security of the controller and the security of the control plane, because if that gets compromised, it's going to be a very larger impact on the system than usual systems that this was very decentralized.
Okay, so some really good thoughts around SDN in terms of security. I think what I hear from the panelists is that it has the features around security controls. It has the scalability to get more security controls around it. Now, my question to the panelists, it's more like a yes or no question. I mean, do you people think that the SDN architecture has evolved based on the security risks? Has it? Yes, no, or does it need to?
I would say no.
Okay.
Does it need to? Yes, because the threat surface increases greatly when somebody can program your switch. Okay. So if somebody cracks your controller, you've got a major security problem. And that's generally ignored in the SDN world as people sort of just try to make progress talking about the separation of the control and data plane. So it definitely has to, but then as I said, even as a use case, it all creates the opportunity.
Okay. Rich, what are your thoughts on it? Do you think it has or it needs to?
No, I agree. I mean, I would actually, add wireless to the discussion because with 5G, the underpinning of the infrastructure is probably going to be a virtualized environment, which would be probably SDN. So, the concept of 5G getting closer to the user instead of backhauling, which is what's happening today. And we know that the service provider community through the standards are not happy with what's happened with 4G LTE, and they want to basically make sure that they come out with a 5G stronger security implementation, and that is riding over top of, it's assumed anyway, that's going to be riding over top of a cloud infrastructure.
Yeah, in fact, yesterday I was reading a LinkedIn post about how 4G LTE is compromisable now. So that's surely a risk in that area. Yeah.
So security is a very interesting topic. You can never say I'm secure. So so it's just saying that you'll be secure at some point is just, and it's not possible. It's not correct to say that. So, but you could always do improvement. Basically, what we have now, you make it more secure, and you at least make sure that if you get compromised by some group of people that really know what they're doing. So, not by amateurs. So that's the main thing that you need to consider in security. So the other thing is that so SDN itself, like a predecessor to OpenFlow, there was a small project. Someone came from the computer security group, just general security, not even networking group, and bringing that view that why everything has access control except my network. Like that was the pre-OpenFlow, like that was the first research project, 2004, that was then evolved to OpenFlow. That the guy basically put the computers like regular towers and NICs in them, and then tried to recreate his own Ethernet network so that frames don't get through one port to the other with what I wanted to do. So
must have been a big nightmare for you guys. Huh?
So it's from definitely what the capabilities that it provides. It's been a huge advancement what it was before, and where it needs to go. Absolutely, there is a lot of work needs to be done. New things need to be included. Device authentication, managing in wireless areas. So the area needs to be expanded a lot to cover more aspects of the security challenges that networks will face, especially given that the hackers and attackers they become more powerful, and many of them they have they're state sponsored, so they're very well funded too. So in that regard, I would say SDN definitely has provided better capabilities compared to the previous legacy networks. However, it still has a lot of work to deal with the other challenges that come out at every moment.
So yeah, good thoughts on it. Since we're talking about security, one of the things which is really important when you're talking about security and security risks is the standards and frameworks. So let's talk more about the frameworks around open architecture and standards in place. Rich, I'll start off with you around the standards around open architecture.
Yeah, so I mean, the reference model that I think most folks are using is the ETSI NFEI model. And, most of the Linux Foundation and supporting organizations use that as a reference model. Organizations like OPNFV, they use that, and they basically show how the interconnection actually happens. So I talked a little bit about standards groups and Linux Foundation and some of these open source community groups. One is a little more structured, is typically driven by industry, although there are researchers there and so on, but typically it's taken a little bit longer for those processes to occur because you need, it's like the United Nations, you need buy-in from everyone. And, when they're making significant changes, everyone wants to kind of think about it and what that means to their organization. So, if the standard goes this way, what does my implementation look like? Do I have flexibility? Can I adopt it? Can I have a software update? Do I need to change an FPGA? All of that kind of thing. So there's some very interesting dynamics, I think, that happen in a standards group. And the Linux crew or the open source crew, they're a little bit different in a sense that they're hey, let's try this, see if it works, fail fast, didn't work, let's kind of check it out. And, so I think that the two seem to be, as far as I can tell, seem to be wanting to work together, because I can see the kind of the benefits from both sides, and I think both kind of could learn from each of the other groups. And clearly security, you can't actually have a networking session without talking about security as the fundamental.
Yeah. Your Corsa's thoughts, yeah.
You were talking about SDN security and NFV.
Yeah.
Yeah.
And then I was saying that are there any other standards or frameworks in use in the open architectures?
Right.
Yeah.
So I haven't seen a lot of effort, particularly in NFV worlds, except for things like the standards and reference architectures that Rick's talking about. But reference architectures for security are a bunch of people thinking the problem through in a room and writing an architecture document. There's nothing to say that they're correct or that it's fully secure and so on. But if you imagine that we set off on a challenge to go and hack AWS, I'd be surprised if any of us in this room could actually make a dent on the security that they have within AWS, because through experience, they're a big target, and they've probably put a lot of effort into securing the infrastructure. Unless you've got a really smart guy, and then maybe he can do that. So I think for NFV and things, the security for those distributed computing models will come out of real best practices that are already in play on large clouds. So I'm not concerned that it won't happen, or that the OPNFV group hasn't solved the problem. I think that's how that part of it will be solved. If you go back to what I was saying about securing the control plane because you put some Python scripts together on campus, that's another problem. And so the separation of the control and data plane doesn't make it easy. It makes it hard. And so depending on the scale and scope of what you mean by SDN, either you're on the hook to really secure your own control plane, or when you're talking about large infrastructure, I think it's because security is already a big problem. There are people that know how to run data centers, that know how to secure them.
Yeah. So Mark, I really want to hear your perspective on this. I mean, in terms of what kind of standards could be used, what kind of frameworks could be used to further improve the security around the open architecture or products out there.
I guess that's not really my my area of expertise or experience.
Hadi, if you can talk a bit about that.
So I would say it's a very fluid area. It's just things are changing a lot. As it was presented today, is just organization merging or different organizations. So things are very actively changing in that area to how to provide better security. NFV, a lot of work recently been moved toward containerization and using microservices or micro NFVs, being a large number, deploying a large number. And using different forms of virtualization for providing NFV services. And that's basically another group that they're working on our own. And it's what I've seen that because it's a very fast-moving environment, many of these organizations like associations, standardization, they usually fall behind, like at least usually a couple of years. So it's interesting to see how the people would actually put things together using these containers and providing this NFV, how they move. I would say that would be a bit better indicator of how things are moving than looking at some of these organization to what they do, because they usually get bogged down over details, and by the time they're done, probably people moved on.
Okay, so I just want to share my perspective a bit, and this is about the leading cloud service providers. I mean, you've got Google Cloud Services, we've got the Microsoft platform, you've got AWS, and one thing which I've noted in the past few years is that in terms of security, they've come a long way. I mean, I found out a few years back, about 2 years back, that the Google apps are ISO 27001 certified. Even the Microsoft platform is ISO 27001 certified. And I think Amazon was also going towards that. Now, a framework or a standard does not guarantee that you're not going to get breached, but it minimizes the possibility of an attack or some case. And I really hope that the open architecture does embrace some kind of framework. I know there's some work going around that, and it's an iterative process, but let's hope that they go towards that thing. And we never know, they might be working on some standard right now in terms of security. Or, I mean, even if they want to have some kind of approach in securing their architecture using some kind of reference framework for that, like the TOGAF architecture, a TOGAF framework or something like that.
Well, the Open Networking Foundation did have a security working group, and they did two things. They looked at the problem of the separation of the control and data plane, and definitely wrote a set of recommendations on how you protect that surface. But the other thing they worked on was testing, and so they actually wrote code that would either try and break a controller or break an OpenFlow switch. And so basically you could walk up with a Corsa switch if you wanted, and since OpenFlow is a standard, you know how to talk to it, they would run their controller and see if they could make the switch misbehave. And so they did a bunch of work to actually give you the ability to test, and that work is out in open source. If you want to test an OpenFlow controller or an OpenFlow switch for security vulnerabilities, you just download it. I think they called it Project Delta, and so both the practical aspect as well as security recommendations were done inside ONF.
Okay, thanks a lot. So we have about a few minutes left. So just want to get some final thoughts about how does the panel see the open architecture evolving in the future. I know we did touch upon a bit, but just some final thoughts on it.
I've bet the organization on it, so to be clear. And I think a lot of the innovation that's happening is in this space. There is going to be some commodity type software and hardware, quite frankly, as time moves on. So things like OCP, where the Open Compute platform, where hardware is effectively commodity, and there's some degree of differentiation, and maybe the model something like 80-20, where 80% is common and 20% you innovate, because let's face it, you have to innovate in business to differentiate, and if you're using all the same stuff, it's your ability to execute and innovate is going to differentiate you. And on the software side, I mean, the sky's the limit from what I can see, right? So the innovation that's happening through containers, through, the merger of making these, like the demonstrations that we saw this morning, it's actually quite complex. And in order for a lot of the, this cloud infrastructure to make it to, let's say, commonplace. And to me, commonplace is when enterprise customers are using it, just like they would use any other technology today. So I think it's here to stay, and I think it's going to be an exciting ride.
Thanks.
I think the bulk of the revolution will come from the edge, and I think it'll mostly be software. We don't know what software yet as people try things, and the abstractions that you want to program at have to be matched with the task that you're trying to program to, and all of that is in flux right now, and it's very hard to predict what the winners and losers will be in that space.
Thanks, Mark. Any final thoughts?
Just quickly, it's as a DNS security provider, it's an exciting platform. Things that we do on legacy networks now are really basic, but the SDN could really facilitate some interesting security features and functionality.
Thanks. Hadi? Your thoughts?
Yeah, just quickly, I think I agree that it's probably edge is the. I believe that the edge and using small devices, starting from small devices, to be able to use SDN's features to secure them, like home gateways, like office gateways, and using overlay technologies to bring these edge access to a central place to manage them. So that would be, I think, a good path to go.
Thanks a lot, and some really good thoughts about the future of the open architecture. I think there's lots of room for improvement and development around the software side, the IoT side, and of course, security is an ever-evolving space, so I think there's going to be lots of changes. Thanks a lot to the panel for sharing your thoughts on it.
Thanks for having us.
Thanks. Okay, so I think we can go to the next room now for the
Yeah,
next
back to
session.
the main room for the last session.
Okay. Thanks.